All right. So today, wanted to talk about agents, recipes in the context of Sirji. So Sirji is a framework of AI agents, and these agents they help developers with their everyday dev tasks. So Kedar, let's start with what is an agent. We talk about custom agents and stuff, but let's just talk about what's an agent in the context of Sirji.
Right. So agent is in Sirji, agent is a modular AI component which performs according to a specified pseudocode. So it performs a task and it has got a pseudocode inside it, and it goes step by step as per the pseudocode to perform that particular task. Before seeing an agent file, let's see what a recipe looks like. So a recipe is a list of tasks. It's an array of tasks, and each task has an associated agent. So for example, in this particular recipe, there is only one task, and it has that task has an associated agent with it.
If there were multiple tasks, so here it's just about creating API. But if this was a sequence of tasks, then each task would have an associated agent with it, right?
Yes, definitely. So, for example, one example could be creating the new API. The next task would have been writing test cases for that particular API. So it will be a different element in this array, and the second task will have a different agent associated with it. So these agents are invoked by another component called orchestrator. So orchestrator, it reads the recipe file, it goes one by one over the prescribed task, and it invokes the corresponding agent for that particular task. So once a agent is invoked, its pseudocode gets executed. So let's take an example of so for this particular recipe, the agent which gets invoked is Node.js create API master. Let's go into the pseudocode of that particular agent. Before,
So it's a YAML file, right?
yeah, it's a YAML file. And let's quickly go over the keys. So each agent has a ID, a name. Even you can specify which LLM to use for inference purpose. So in this agent, the model GPT-4o model is being used for inference, and the next key is sub agents. So it's quite a modular architecture. So the orchestrator invokes one agent, that agent can invoke some other agent. So that agent, the agent which gets invoked from an agent is called a sub agent. So if you mention some agent in the sub agent, this particular agent will be able to invoke that agent. So for example, in this agent Node.js create API master, it is having two sub agents, Node.js create API planner, and we can see in the point number 2 that in the pseudocode it is invoking this agent for performing some other task. So it knows, it has broken down a task into subtasks, and for each subtask, it is now calling different agents. And this is the sub agent which gets called, and a sub agent is actually like an agent. It is having all those keys. It is having a pseudocode of itself, and so this particular pseudocode gets executed when the agent is invoked.
Right. So tell me though, why do you need this agent? But the reason I'm asking is that these days, the people with all the LLMs out there and certain tools as well, you can provide a prompt and expect the LLM or the tool to generate the code for you. So in such a case, then why do you need to give so much of instructions. Looks like pretty detailed pseudocode over here. Now, why?
Right. Before discussing the why, let's quickly go through what are the challenges which LLMs come up when working in existing repositories. So, for example, if there is an existing repository of 100 plus files, those files which will have different coding conventions, uh, different design patterns implemented in those files. Uh, your So whenever a developer makes a change for one particular API, let's say, uh, that developer has to go through n number of files and make changes in those files. And all those changes combined make that API work. So uh,
So which files to write into, that's you need to tell, I mean, you need to instruct the LLM about it, or without that, it's not able to understand. Is that what you're saying?
yeah, right. So it should know the folder structure of your repository and the basic understanding of which files to read, which files to make changes to in order to uh, perform on a particular task. So, eh, so a particular task can be performed in n number of ways, right? So there is no one certain way which is correct. So if you have an existing repository, there will be existing conventions around where you store your global constants, where you store your service
Can
files.
you talk about, or in this context, what do you mean by those conventions?
Right. So let's see a concrete example. So this is a demo repository which we created for demoing Sirji. So in this, this is a Node.js repository, and we are using Express framework. Uh, so there is a route file which has a list of routes, different routes for a particular endpoint. So if I want to write a new API in this repository, I will have to include my route in this particular file. Then I will have to create another service. So there is a concept of services, and this is not a standard concept, standard convention. Some repositories might have entirely different conventions. Some people write their logic inside the route file. Some repositories can have lib files which gets called from the route file. Some have services. So there are different conventions of writing the same API. So this particular repository, it creates a service, and from inside the service, it calls the storage file for doing some inserts, updates, or fetches. So so there are multiple files which get edited when a single API has to be implemented in this repository. So uh, these are the conventions I was talking about, that some file, the LLM should know which files to touch, and the LLM should also know where to get the conventions from. So talking about the conventions, there are also ESLint rules which needs to be followed. So for example, there can be one rule that semicolons are not allowed. There should be no semicolons in the JavaScript files. That can be one of the ESLint rule. So if the LLM is generating code which is not as per your ESLint rules, it will look very different from other files. Even in a single file, if a small patch is generated by LLM and the other file is written by your developers, then that patch will look very different from the other parts of the file. So we don't want that, right? The code which is generated by the LLM, it should fit as uh, uh, it should fit as much as possible into the existing conventions.
Sure. And you might have written, like, there might be design patterns that you're following. You might have written like open API specs or sequence diagrams, and it needs to be followed. Those needs to be followed. So sure. I think it's not too different than, you have a new person joining your team and she needs to be onboarded. I is that similar, right? I mean, it's to onboard a new person, you need to explain her uh, how you do things, and so it's not too different over here.
Right. And additionally, once these agents are written, they if I have written an agent for creating a new API and I keep on creating new APIs on an everyday basis, then it's quite reusable in that sense. Once written, we can reuse it for n number of times for similar tasks.
Got it. All right. So do you also want to talk about the project folders or the agent output folders?
Right. So project folder is the folder which has got which contains the code files, documentation files. As the name suggests, it's the folder of your project, where this particular folder you might be cloning it from a particular repository on GitHub or other version control systems. So this is the project folder. The other thing is, which you mentioned,
More
is
interesting thing is the agent output folder.
the agent output folder. Yeah, the agent output folder. So before explaining what agent output folder is, we just now saw that for a particular task, one particular task, multiple agents were collaborating with each other, right? So there was one master agent which invoked some sub agents, and so there are more than one agents for performing a single task. Now, if they want to collaborate, they need to communicate with each other. The output of one agent might be needed to other agents. So to make that possible, we have come up with the concept of agent output folder. So let's see one example, one concrete example. So if we see here, Node.js create API planner, it has created a file called implementation guide. So this one got created by
We are still seeing the YAML file. Are you looking at
yeah.
it?
So
Okay, yeah.
this YAML file, this particular line 45 in the pseudocode, it says that store the implementation guide in the agent output folder. So when this particular line gets executed, what happens is this implementation guide gets stored inside of the agent output folder. And if we just go to the agent which invoke the planner, so in this particular second line, the planner agent was invoked. And if you just focus on the third point here, it says that read the implementation guide created by planner from the agent output folder. So one agent is storing something in the agent output folder and other agent is reading from the agent output folder. So this is the kind of communication I was referring to. The output of one agent is used by the next agent, and it then works on it. It can update it. It can invoke other agents. And this keeps on happening. So this agent output folder is the common database, if we can visualize it like that, where different agents are storing, retrieving information to and from.
You're talking about writing files, reading files. Is that something that each agent does that, or uh, does do each agent call some other agent for that? How does that happen?
Right. So the capabilities like reading a file or uh, writing to a file are handled by a agent called executor. So in here, I'm just showing you the architecture diagram. so that I can easily explain what I'm talking about. So there are some capabilities which are needed by all the agents. The examples of these capabilities are file system access, that is read, write to certain files in your project or in the agent output folder, as we just saw. Then searching through files for a search term, finding something and replacing it with some other thing in a single file, inserting code in a particular file, then even your terminal level capabilities like installing packages, executing some commands, running a code, running test cases. All these capabilities are exposed, uh, are made available to all the agents by a special agent in the Sirji framework, and that special agent is called executor.
Yeah. Cool. I think all of this would also make sense more when we talk about the messaging protocol that we have developed, but I think that's a topic in itself, and we'll talk about it separately. But good. I think this was great. Thank you, everyone. Thanks, Kedar.
Thank you.